Okay, so we're recording the session. Thank you for stopping by. This is the second session for week one. And tonight we're going to continue from where we left off, which was question number 5. Um, and again, I would like to ask for some volunteers. It really helps me, as I'm doing problems. If there are any repetitive questions, if you can please just go ahead and type the answer, that would be fantastic. And then if there's anything, where um, you feel that you would like an answer from me, then my request is to just wait until I finish the problem, and then I will um, go over your questions. Okay. The first thing I would like to talk about tonight is next week's schedule. So I have a traveling schedule next week towards the later part of the week until the early part of the following week. So what I was thinking was if it's okay for us to do the first session on Monday and then the second session on Tuesday. So would that be okay? And of course, don't forget we're gonna be, we record all these sessions. So even if you can't make it and you really want to be in the session, you can always view the recording. Okay, great. Everyone says yes. So thank you. Thank you so much. So that's what we'll do. I have already updated the calendar, the course calendar. So the first session is on Monday. Okay, so let me share my screen. Please let me know if you can see my screen here. And okay, so if you can just say yes, you can see my screen. Okay, great. Where do you view the recording? So let me show you how we can see the recordings. And yes, this is one of those repetitive questions, so it would be great if someone can answer, but I will show you how to access it. So when you're in your course, so say you're in your course in the Blackboard shell. Okay, still loading. Okay, so when you're in your Blackboard shell, you'll see that there is a link to webinar information. Okay, so if you click on webinar information and you scroll down, you'll see that there's a course calendar. And in this course calendar, under Tuesday, which was the 25th, you'll see that there is the original entry for the webinar. Okay, this was the webinar schedule. Right underneath it, I have posted the webinar recording. So you can just click on this and it will start the recording. Okay, that's one way to do it. The other way is to remember I mentioned you can access um, Professor David's um, Professor David's website. Okay, so that's the link. Hope you can see it, but this is the link, and I can post it in the chat box. And once you go there, just scroll down and take a look at this webinars tab. If you click it, you'll see that um, for this term, I'm going to be posting the recordings in this column right here. So I've already posted Tuesday's webinar here. So there will be a Thursday webinar tonight. And the nice thing is that you already have all the webinar sessions from the previous term. So if you want to work ahead, you can go over these sessions that we recorded in the last term, okay, which is I think it's an excellent resource. And just in addition to that, this website is really nice because um, David has all these different um, solutions to the problems, and he explains it in great detail. And then he also has some videos and some links to the course concepts. Okay, so this is something you should be looking at every day, I think. Um, and look at this, it even has the Journal 1 aid, which is also it's posted in your course, but I think it's just so nice that you can access it here. And every week has all these different uh, you know different links and information. So please make sure to view this, okay? Alrighty. So with that, let's get started. We have quite a few problems to do tonight, about 10. Generally, in the first week, because the first session is an introduction session, so we we do fewer problems. From next week, you'll see that we'll be covering approximately 7 to 8 problems and the concepts behind them in each session. So, okay, so let's get started. We have how many? 63 students tonight. A little bit less than last time. All right, problem number 6. The following data represents monthly cell phone bill for a person's phone for 6 randomly selected months. Okay, randomly is important because so we're not biased. Okay, um, so we're randomly selecting maybe from a year, 6 months, and here's the cell phone bill for those 6 months. The question says compute the mean, the median, and mode phone bill. So we all know what the mean is. What is the median? What do you think is the median? Yes, it's the middle value. Very good. But to be a little more precise, it is, so say I have 21, 27, 23, 19, and 31. So in this case, what do you think is going to be my median? Okay, a lot of you are saying 23. Okay, let's see. So there are 2 steps involved, okay? And Michael is absolutely right. We have to first, Michael and also Linda, we have to order it in ascending order, right? So we have to rewrite it in ascending order. So let's write that. So we have 19, which is the smallest value. Then we have 21, then we have 23, then we have 27, and then we have 31. Okay, and you all got it right. It's a one of those coincidences, but yes, 23 is the median. Now, what if this value was 28? What if this was 28? So now it's 28. So what is the median now? Everyone says 27. Well, let's see. If I rewrite it in ascending order, I get 27. Very good. Okay, the middle value is 27. Now you may ask what happens if I have one other value, say I have 32. Okay, instead of 32, say I have 35. So what is the median this time? Yeah, so now we have even number, right? So the first step is the same. The first step is rewrite in ascending order. Okay, 19, 21, 27, 28, 31, 35. But now there's no middle value. There are 2 middle values, right? These 2 are the middle values. There's no one middle value, right? So what do you have to do? You have to take these 2 values and average them. And so um, Randy, Robert, Sandra, Lisa, everyone's correct there. It is 27.5, okay? Because you take the average of the 2 and it's 27.5. Okay, so that is the median now. Okay? So very easy. The first step is to put the data in ascending order. And then if you have odd number of cases, like in this case, right? You have odd number of cases, there are 5 of them, then there is a middle value and that is your median. If there are even number of observations, like in this case, there are 6 of them, then there are 2 middle values, so you have to consider them both and take their average. Okay. If you have time-based data, I'm not sure if I understand that question. Median in the sense for now is going to be you're going to have um, continuous. So let's wait for that until next week because we're actually going to be doing a continuous distribution. And you'll see that in that continuous distribution, and I wonder if you guys know what I'm talking about, but in that in that distribution, the mean and the median will be both in the middle and always. Can someone guess what I'm talking about? What kind of distribution am I talking about? What is the distribution that has the mean, the median, and the mode all in the middle? Yep, Peter's got it right. Michael's got it right. It is a normal distribution, which is also, it's called a bell-shaped distribution as well, because the shape of the distribution is like a bell shape. And the center is where you have the mean and the median and the mode. But we'll talk about that next week. Okay. So this is the median. And what is the mode? Can someone tell me what the mode is? The most popular, yes, repeated number. To be a little more precise, the mode is the number with the highest frequency. Okay. So for example, in this case, what is the number that has the higher frequency? Not the high number, frequency, right? Not the largest number. The largest number will be the maximum. Yes, 3 has the higher frequency because 3 occurs twice. All of the numbers occur once, right? So 3 is the mode here. So the mode in this case is 3. But what is the mode here? Very good. Excellent. There is no mode because no number here occurs more than once. All numbers occur just once. Therefore, there is no mode. Okay. Good question, Peter. There is no, I mean, the mode is like, I would say the least popular of all three descriptive stats. Okay. Like the mean and the median. Mode is the least popular and the least sort of known and the one that has the least value. But again, next week we're going to study a distribution where the mean, the median, and the mode all have, they're all there and they all have a value, and so we'll discuss that in a little bit more detail. Okay. So now that you know how to calculate all these different descriptive stats, let's do this problem. So here's the data. Okay. Now I'm sure you can calculate the mean, the median, and the mode for this data by doing it manually, which I just showed you. But I want to show you how to do this in StatCrunch. So let's open this in StatCrunch. Can you all see this, by the way? Can you see it clearly? Do you want me to zoom in? Okay, 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 great. So let's open this in StatCrunch. All right, here we go. It's a little bit larger now. And did it open? What happened? Here we go. So I'm opening the data set. By the way, did you notice how I open it? So I opened it by, hovering over this box, clicking, and then it says open in StatCrunch. So I'm going to open this in StatCrunch. And now here's how you're going to do it. Now follow this here. This is pretty important. It's really the first time we're going to use StatCrunch, the descriptive stats part of StatCrunch. You're going to click on stat. You're going to click on summary stats, and then you're going to click on columns. Okay, so stat, summary stat, column. Okay. Yes, Randy, this is exactly how you're going to access your data. And then you're going to select the columns. Okay. Going to click on var1, which is var1 is where you have the data set. Okay. So select that and then look at this. You can select any of these statistics. Okay. Any of these statistics. So I'm going to select the mean first, and then it shows up here. Then I'm going to select the median. I'm going to scroll down until I see the median, and I'm not going to click on it. Okay. First, I'm going to hold the control key on your keyboard. Okay, so I'm going to hold the control key and then click on median. And that selects them both, mean and the median. And then similarly, the mode is at the bottom of this list. And I'm going to, again, hold the control key, click on mode, and it selects all three that I need. And I'm going to hit compute and take a look at this. It gives you the mean for the data set, it gives you the median for the data set, and then it tells you that there is no mode. Okay, this is how easy it is to do it in a, using a statistical package. You can do this in Excel as well. Okay, but I think it's good to know StatCrunch. Part of the reason is because it helps you to get to know higher level statistical packages like Minitab. Minitab works very much the same like this. So yeah, there is no pen and paper, and the reason is these calculations are going to get really complicated from next week. If you are going to be doing this by hand, some of the problems from next week will not be solvable. So you're going to have to use a package, something like StatCrunch or Excel. I just prefer StatCrunch because I think it's a good introduction to these packages. Okay, but this is the answer here: 41.39 and 40.77. And then there is no mode. So the answer, mean is 41.39, median is 40.77, and there is no mode for the phone bill. Any questions here? I think it's pretty simple, right? Okay, let's move on to the next problem. All right, now here, okay, so try to follow this piece. I'm gonna do it a little, using a little bit of a trick. So I'll show you how I did it. A random sample of 15 students were asked how many hours per week typically do you work outside the home. Their responses are on the right. So here are the number of hours they work outside the home. Okay. Determine the shape of the distribution of hours worked by drawing a frequency distribution and computing the mean and the median. All right. So the first thing to do is you have to make a frequency histogram. A frequency histogram is very simple. The x-axis is the same unit as what's given in the data set, and y-axis represents the frequency. So, and then you have bars representing the frequency. Okay, so for example, take a look at this. All these three options have x-axis, the bars of size 5, right? So for example, this is from 0 to 5 right here, then 5 to 10, 10 to 15, 20, 15 to 20, and so on. So that's the first thing to notice. So now, if I were to do this problem, this is how I would do it. You don't even have to create the graph. Process of elimination. Robert just read my mind. Very good, Robert. Yes, so that's what I'm gonna do. I'm gonna see what kind of data do I have, and then I'm gonna eliminate the wrong, options. So let's take a look. So for example, let's see how many I have from 0 to 5. So I got 1, okay, that's 4, so that's 1, and then 2, right? Because there's 1 here. So between 0 and 5, I have a frequency of 2 because there are 2 observations that fall between 0 and 5. So let's see. This graph is wrong because from 0 to 5, it shows that you have a frequency of 0. So that's wrong. So you can throw this out. Okay, now this one. 0 to 5 has frequency of 2, so you have to keep it. And let's go to the first one. 0 to 5 have a frequency of 0 again, right? So this is wrong. So that leaves me with only this as being the correct answer. So I'm going to choose this as the correct answer. Okay. So sometimes you'll see that some of these tricks can be, fairly neat because you don't have to actually go forward and actually create, the graph or do the analysis to get to the answer. It's a good practice to first just take a look at what kind of data do you have and what are your options, and then do the process of elimination. Okay. What's more important about this? Yes, yes. So that's right. Yep. I mean, if you do want to create the frequency histogram, I mean, right, this is very easy, right? Because what you're going to do is for each of these, bars, we know that the separation is of 5. You just have to create a frequency table, right? So between 0 to 5, I just counted 2. Between 5 to 10, what do I have? 1, right? There's only 6 that falls between 5 and 10. So there's only 1. And once you have the frequency table, then it's just a matter of basically taking the table and just creating bars out of it. So it's very simple. But in order to, if your question is that enough to get the credit points? Yes. Yes, it is. Okay. All right. Now, is the histogram for data skewed right, skewed left, or symmetric? So remember we talked a little bit about skewness. So is this skewed left? skewed right or symmetric? And that's okay if you can't answer because I'm going to go over it right now. Okay, Randy says right, Kimberly says left. Okay, skewed right, skewed right. And the answer is skewed left. And let me tell you why. So, the first thing to do is to ask you, is there a skew in this diagram or in this distribution? Is there a skew? No. Why? Yes, because it's bell-shaped. This is a bell-shaped curve. There is no skew in this distribution. Okay? And how can you have some kind of a distribution like this? Well, maybe say that the center is 15. So you may have a lot of 15s in your data set. Okay? And then you may have some higher numbers and then some, fewer numbers here, right? So clearly 15 has a frequency of 4. It has a peak here. So this data has really no, uh, you know, this data set is not skewed. Now, you may have data that's skewed. For example, if I just keep adding 20s here, right? Now the frequency of 20 has gone up, and you may have something like this. In fact, because there are 4 of them, there are 4 20s and 4 15s. You almost have a graph like this, right? So where's the skew here? What happened to this? Where did you get a tail going from this diagram to this diagram? The tail is on the right side. Yes. Because what happened was you introduced more 20s on the right hand side, and what happened is now you have a tail. Generally, a skewed distribution is displayed as this. Okay, you have a tail, and this tail is on the right side. Okay, this is the long tail on the right side. This is right skew. Okay, a tail is called something where you have data on the edges of the distribution. So when I say the tail is on the right, the edges are, you have data on the right hand side of the distribution, extra data. Yeah, like outliers, for example. That's right. The outliers are on the right hand side. And then similarly, you can have it on the left hand side. So then the data distribution will look like this. Okay. Now let's take a look at this problem so that I can tell you how this is left skew. So you can see that these 3 bars here, right, are symmetric, right? You can see if I zoom in, these 3 bars are symmetric. But then you have these kind of like almost like outliers, aren't they? Right? The outliers happen to be where? On the left hand side. And so this here, since you have something like this, oops, right? And then you have something like this. This is almost like saying, remember my diagram with the tails? It's almost like this. The tail is on here. Here. See that? Because of this data, your tail happens to be on the left side. Okay, that's how you identify um, where your skewness is. This is left skew. Okay, if this data was here on the right hand side, this would be right skew. Okay. If you have any connection issues, sometimes if you log out and log back in, usually it resolves it. But be careful. Tonight is not going to be an issue, but if we have 100 students, or maybe it's 120, then there's a limit of users who can be in the room. But tonight that's not an issue. So the skewness is, okay, let me explain it a different way. Take a look at this data. Do you see this data? Do you see how most of the data is concentrated between 10 to 25, right? So most of the data values are between 10 and 25. But take a look at these small numbers here, 1, 4, and 6, right? So you only have three small values. All of the values happen to be not even 10. It's almost like 15 to 25, right? So you can see why you have a left skew, because you have these small values 1, 6, and 4. So for example, this represents 1 and 4. This represents 6. And then all these values are the rest of the values that are between 15 and 25, right? So therefore, your skew is on the left side because that's where the numbers are smaller, right? When you write these numbers on a number line, 1, 4, and 6 are on the left side. Okay, so that I hope that makes sense now. Because Jennifer, that's the definition of skew. Skew means where are your outliers. Skew doesn't mean where are your most of the numbers in the distribution. Skew simply means where are the outliers. Where are the numbers that are not really a part of the distribution but are very different, right? In this case, here are your most of the data values. They occur in the center here somewhere. And then you have these residual values that are occurring outside of most of this distribution, right? Hence, they're called outliers, and hence they cause the skew to move to their direction. Okay? So, all right. Yes, that's right. Okay, so now we know where the skew is, and then the next question is the mean number of hours and the median. So we need to calculate the mean and the median. So let's click on the box and open this in StatCrunch. Now, once we open this in StatCrunch, let's calculate the mean and the median. Okay, so I'm going to go to Stat, Summary Stats, Columns, and I'm going to go to var1, and I'm going to choose mean and the median. Just like I did before, I'm going to choose both of the mean and the median. When I hit compute, I get the mean is 18 and the median is 20. Okay, so the mean is 18 and the median is 20. So here it is. The mean is 18, the median is 20, and which measure is better? Now, this question is important. The question is, which of these two, the mean or the median, is a better estimate for this kind of distribution that has a skew, meaning that has some outliers? So what do you think is, we briefly talked about this, um, on Tuesday. So what do you think is a better estimate in this case? And then I will explain which one is better. Okay, so some are saying the mean, some are saying the median. Those who are saying the mean, can you tell me why do you think the mean is? Average? Okay. Now let me give you the answer first, and then I will explain why the answer is correct. In this case, the median is a better estimate, and let me tell you why. So I'm going to show you a very simple example. Okay, I've opened this in Excel. Here's a very simple example. Okay, take a look at these 5 values. Okay, 5 values are 25, 21, 23, 29, 29. The average is 25.4, and in this case, the median is 25. You can see that the mean and the median are almost the same for this, right? They're almost the same. Okay, now say that I take this data and I put it in column B, and say that I introduce an outlier. Okay, so I'm going to introduce an outlier, and I'm going to introduce a really large outlier. Okay, so I'm going to introduce, say, for example, instead of 29, this last value being 29, I'm going to put 2900. Okay, really, really large value, does not follow the distribution at all. Okay, now let me hit enter and see what happens. You're going to see what happens to the average and the median. So here we go. See that? Look at what happened to the average. The average shot up, after I introduced 2900 in the distribution. But take a look at the median. The median did not move at all, right? It did not have an effect. because of this large value. So why is the median a better estimate? Because the median is prone, okay, to to outliers. The median happens to be safeguarded, okay, when you have these outliers. The median is not going to move much. It will move a little bit. When you have many outliers, it will move a little bit, but it is not going to move significantly like the average does in this case. Can someone tell me why that is? Can someone tell me why is it that the average moves that much and the median doesn't? It's a very simple explanation. Let's see if someone can come up with it. Why is the average moving that much? Yeah, but yes, Robert, but I'm really asking for the reason. Why do you think that's happening? Christy, it doesn't. Close, but it doesn't. Very close answer though. Just have to think about it a little bit differently. Yes, so I think I have a few good answers here. Okay, here's a reason why. The median looks at the center value, right? It's looking at the center value. So let's take this data and let me put it in ascending order. So I get 23, 21, 23, 25, 29, 2900, right? The median is not using the values themselves, right? The median is not actually using the values themselves. It's using their ordering and is saying, here's the center value 25. That's all it cares about. It does not use the values in any calculation. But what does the average do? The average uses this, the average or the mean is equal to the sum of the values, right? Divided by how many values you have, n of the values, right? Because it uses the sum, what you're going to do is you're going to be summing all this. And when you sum all these values, you get a really large value because of the 2900. And that is the reason why the average shoots up, okay? So in this, whenever you have outliers, whenever you have skewed distributions, the median is a better estimate than the mean. And Rachel has a very, very good question. So would mean be a better estimate for a bell-shaped curve? And the answer to that is either the mean or the median is a good estimate for bell-shaped curve. But we generally prefer the mean for bell-shaped curve, okay? So anytime you have outliers or skewed distributions, use the median. Otherwise, use the mean. Okay? Any questions here? I hope I was able to explain it with this, simple little data set. So in this case, because we had a skewed distribution skewed left, we will choose the median. Okay? Excellent. All right, let's go to the next problem. Okay. All right, now, so far we have talked about the center of the distribution, right? So a distribution, say a bell-shaped distribution, has a center, right? And we've talked about the mean or the median or the mode, as being descriptive statistics for the central value of a distribution. But I can have this, right? So you have this distribution, but I can also have another distribution, which I'm gonna exaggerate a little bit, okay? I'm gonna put, all right. So can someone tell me, and let me actually, let's forget about this distribution. I'm gonna make one here. I'm gonna make it like this. Can someone tell me what is the difference in these two distributions? As you can see that the average, and I'm gonna give you a hint, the center is the same for both. So what is the difference? The center is the same, so they're gonna have the same average, median, or the mode. What is different here? Absolutely right. Christy has exactly what I was looking for. Spread. This has more spread. This has less spread. So wouldn't you say that it is, in addition to calculating a central value, it is also important for you to calculate, some kind of statistic on the spread so that you can visualize the distribution. So wouldn't you say that's a good idea, right? I mean, if I were to just give you the center and I tell you, hey, hey, Robert, here's the center. Can you create the distribution? How does the distribution look like? You're going to say, no, I can't because you only gave me the center. I don't have enough information. I don't know how spread out the distribution is, right? You're going to ask me that question. But once I tell you maybe say a statistic on how, spread out it is, you can maybe create a rough draft of how it looks like, right? So that is the reason why we're going to now study one of the most basic, um, a basic statistic of spread, which you're probably not going to see it again because it is so basic that we're never going to see it again. But it is, after all, the first step towards calculating something, that's useful. It's called the range. What do you think is the range? Range is very simple. Range is just the maximum value minus the minimum value. Okay, so compute the range, and then it talks about this sample standard deviation, and we'll talk about that. But for now, the range is simply take the maximum, subtract the minimum. So let me open this data in StatCrunch for now. Let me show you how we do that. So I'm gonna again go to stat, go to summary stat, columns. Okay, this is what we've been using tonight. So make sure to practice with it enough. Then you select the column and then go and look for the range. Okay, so you have a range as well. You have the minimum, maximum, and range. But for now, you can just select the range, hit compute, and here's your range. 1150 is the range for this data set. That is your answer. Okay, so can you all tell me if that's okay? Did you follow the range here? Okay. Now we have to calculate something called the sample standard deviation. Okay, so sample standard deviation. Okay, I know that this sounds very, you know, probably sounds very scary, but it's not that bad. What it's doing here is it's saying, first of all, it's sample based. So you have a sample of data values. So here are the data values for the sample. Hence, it's called sample standard deviation. So let's say we have covered this. Okay, so let's forget about this. We know it's a sample. Now we have standard and deviation. So what do you think this deviation represents? What do you think the deviation suggests? Aha, Christine. Very, very good. Variance from the norm. Basically meaning the normal, wherever the normal values are. How far are you from it? So maybe we can say, how about I say, maybe it's how far are you from the mean, the average of the distribution, right? Wouldn't you say that's okay? How far are you from the average? So for example, say I have these 5 values. So let me just write out these values. So I have 39, 10, 41, 40, 3300, 3200, and I'm just gonna write out 1, 2, 3, 4, 5 of these. Okay, so say I have these values. Now the first thing I'm gonna do is I'm gonna calculate their mean. So let me calculate the mean, the average. So for this, let me just use my neat little scientific calculator. I'm gonna add them all. Okay, and I will calculate their mean by dividing by 5, and I get 3508. So the mean of these 5 values is 3508. So I'm going to say the mean equals 35.8. Now, what I would like you to now, you know, um, understand something, and you'll have to remember this the rest of this course, is that this is it. First of all, this was a sample, so this is a sample mean. Okay, sample mean in statistic is, yeah, sorry, this should be 3508, not 0.808. Thank you. Yes. So we know that this was a sample mean, right? Because it was based on a sample. So sample mean in statistics is represented by x, and we call it bar. Okay, x bar, the small x bar. So it's kind of like this. Okay, but it's x bar. X bar means we're talking about sample mean. Okay, so this is the same as x bar. Okay, now let's talk about deviation. Deviation. Okay, so deviation means how far are you from 3508. So let's talk about the deviation for this value. How far is this from 3508? Very simple. I just take 3910 and I subtract 3508, right? How far is this value from the mean? Well, I just take 4140, subtract 3508. Okay, how about this? 3300 minus 3508, and so on. Okay, the same way for the rest of the two values. Now, what we're going to do is sometimes you can imagine, sometimes you're going to have, like for example, in the case of 2990. So when I type 2990 minus 3508, I'm going to get a negative answer here, right? I'm going to get a negative answer here, but I'm going to get positive answers here. Okay, like here it will be negative, here it will be positive, here it will be positive, and then negative and negative, right? So why don't I, in order to calculate, always get positive values of deviation, how about I square the result? Because when I square the result, the positive values will always be positive and the negative values will become positive, right? So for example, in the first case, I have 3910. I take 3910, subtract 3508, I get 402, and I square it, I get 161,604. Okay, so I get 161,604. And then similarly, say I take a negative value, 2990 minus 3508. Now I'm getting minus 518. But when you square it, right, when I square it, here's a square button. If I square it, I get a positive value, 268,324. So 268, 324. See that? Now all these values are going to become positive. Okay, so I'm going to stop here. Tell me if you're all following this so far. Yes, good question, Robert. Why not? Why not? You can do the absolute value as well. In fact, there is a standard deviation. It's called absolute deviation. So that's a good point. Standard deviation by default, involves squaring the values. Okay, everyone's following. Excellent. Okay, so what I did was I took the deviation of each of the value and I squared it. Okay, all I have done is this so far. Now, here's how the standard deviation is calculated. If you followed this, I'm going to go to a new slide. So you followed all this so far. So in fact, let me just do it here. I'm going to do it here. Standard deviation is standard deviation simply equals you sum deviation square. Okay, so you sum all these squares that we calculated and you just divide it by n minus 1, which is how many numbers you have. In this case, we had 5, and you subtract 1 from it, and then just take the square root of this whole thing. Okay, so let me go through this again one more time. You take your deviations, okay, each of the deviations, and you square them. Okay, so this is what the square is. Then you sum them all. So basically, I took my deviation, I squared it, I got all the squares, I'm going to sum them all, I'm going to add them all. And then I divide them by n minus 1. How many values I have? 5. So I'm going to divide 5 minus 1, which is 4, and then just take the square root of that. Yes, n is the number of sample size. Okay, Lorena, that's what we're going to call it, sample size. So how many observations we have in this sample? 1, 2, 3, 4, 5. Okay. So Donna, remember I said we're going to square them because sometimes you're going to get negative answers. Sometimes you're going to get positive answers. You square them so that all your answers are positive. Okay. And the reason you do that is because you don't want to subtract numbers from a positive number, because then that reduces your deviation. You want to always square it so that all numbers are in positive form. Okay. Yes, I'm going to show you how to do this in StatCrunch. But like I said, it's good to know the theory behind these statistics so that you know what StatCrunch is giving you, right? If I just showed you how to do this in StatCrunch, it's not really going to make enough sense when when you see a problem on this. Okay, so this is what a standard deviation is. How simple was this? All I did was calculated the mean, got my deviation, squared it, got all my squared deviations, all of them. I added them all, and I divided by n minus 1, and then I took the square root. This is my standard deviation. So I'm going to go to a new slide now, and I'm going to say that my standard deviation is simply don't be scared. This is the same way of writing what I just wrote earlier. And I will break it down for you. Okay, so let me break this down for you and then we'll go to StatCrunch. X bar, remember what I said was X bar. X bar is the mean, right? We said it's the mean. What is X minus X bar? X minus X bar is the deviation, right? X is any value, take any value in the data set, subtract mean from it, then this is the deviation. Then remember I said you square the deviation. So I have a square. I'm squaring the deviation. Okay. Then remember I said sum all the squared deviations. Well, that's why I have this sign. This sign means sum. Okay. Means sum. So what am I doing here? Sum of all the squared deviations divided by n minus 1 and square root. This is exactly what I just showed you just a few seconds ago, right? Do you all agree? Do you all agree that this is exactly the same? Okay, now you're not scared of these really weird looking signs anymore, right? You know that this means the sum. You know that X means a value. You know that X bar means a mean. You're becoming, you're almost like in the matrix now, right? You can see what these different, you know, all these different weird looking symbols mean. So I tend to think of this class as, as if you're in a matrix, because you're going to see a lot of these notations in the upcoming weeks. And so the lower n is the sample size. Remember I said in the previous case, in this example that I just gave, the sample size was 5. So we have 5 minus 1, 4, right? And then you have a square root. Okay. Now, this is the standard deviation. This is the definition of standard deviation. I also want to introduce one other thing, and it's called the variance. And the variance is simply you take the standard deviation and you just square it. Just square the standard deviation. Take the standard deviation, just square it. Okay, which basically just gives it gets rid of this square root. Okay, that's your variance. Now, remember I said deviation is how far are you from the mean, right? So standard deviation is actually measuring how far you are from the mean, except that it is standardizing everything, because you're dividing the sum of the squared, sum of the squared deviance with n minus 1 with the sample size. So what you're doing is you're standardizing, the deviations, the sum of the deviations. This is why it's called standard deviation, because you take your deviations, you sum them, you sum their squares, and then you standardize them by dividing by n minus 1. This is the reason it's called standard deviation. Is everyone clear on this now, so that I can go in StatCrunch and show you how it's calculated? Okay, you can do this by hand also now. If you just follow everything I wrote in the previous example, you can do this by hand. But this was the reason why I was telling you that we're gonna be interested in doing these problems using a software package. So, okay, you calculated the range. Now let's calculate the standard deviation. So I'm gonna go open this in StatCrunch again. And I'm gonna go to stat. Okay. Summary stats, columns. This is exactly what I've been using so far. Select your column. And now look for standard deviation here. So where do you see standard deviation? Do you see standard deviation here somewhere? Yeah, very good. You caught it. S Here is STD dot DEV dot. Okay, that's standard deviation. Click it. You're going to select it, hit compute. Actually, let's also do the variance. Okay, so I'm going to choose the variance as well. So hold the control key, click on variance. Now I have both standard deviation and the variance. Compute. And here we go. We get our standard deviation is 456.32, and here's the variance. Let's verify that standard deviation is really, when you square the standard deviation, you should get the variance. So let's square this thing. If I square it, I get 208, 228.57. See that? It's exactly the variance. So you just square the standard deviation, you get the variance. It's not an average of the deviations, Robert, because remember you're squaring them, right? So because you square them, it's not really an average. But what it is the standardizing the squared deviations. Okay, that's what it really is. You take your squared deviations, add them, and you divide them in order to standardize them. Okay. Now, what does this number represent? Let me ask you. What if my standard deviation, say I have two different standard deviations. Tell me which one means what. So say I have a diagram that looks like this and a distribution that looks like this. Okay. And now say I have standard deviation, I have two values. Say I have whatever, 23.3, and say the second one is 873.2. So which one do you think, which one of these diagrams do you think, or distributions, may have a standard deviation of 23.3? Very good. Yes, this one. Why? Because this shows less deviation, right? This shows less spread. So standard deviation will be a smaller value in this case. Very good. And then this, because it has very large spread, then it should have a higher value of standard deviation. Okay, so yes, so standard deviation is a way of measuring spread. If the standard deviation is a small value, there's less spread. Standard deviation is a large value, there's large spread. Okay, but for now, all you have to do is calculate it, and here it is. Okay, 456.3. Let's go to problem 9, and let's take a look at this. So the following data represents the flight time of a random sample of 7 flights from one city to another. So here are the flight times in minutes. Now they want to compute range and the standard deviation. So very easy. This is just like the previous problem. Go in StatCrunch, go to Stat, Summary Stats, Columns, var1, and you can then you're gonna select the standard deviation and also select the range. So select both, compute, and look at this. We got standard deviation is 8.83, the range is 27, and that those are your answers, 8.8 and 27. By the way, I do want to remind you, for every problem, make sure to look at what kind of precision the problem is looking for. In this case, the problem is looking for 1 decimal place. So you should put in your answer rounded to 1 decimal place. So in this case, see, my answer was 8.83176. Well, you have to round it to 1 decimal place. So the rounding here gives you simply just 8.8, and that is the answer. Okay. Okay, I think this was very simple, right? Any questions here? This is a good question now. I think this will be very helpful to do. So what do we have? The following data for a random sample of banks in 2 cities represents ATM fee. So these are 2 different, this is city A and the ATM fee, okay, of a random sample, or a random sample of ATM fee, okay? And then here's city B, and then similar. So basically what we're trying to do here is we're trying to see what kind of differences do we have in in the spread of these ATM fee in the 2 different cities. So let's take a look at what do we have to do. So first, we have to find the range and the standard deviation for both. So let's open this in StatCrunch. See, when you open this in StatCrunch, now you get 2 columns, one for city A, one for city B. Okay. Yes, Sandra. Maybe I should read the problem. So the problem says which city has more dispersion based on the standard deviation? Yes, dispersion and spread are essentially the same. Okay, good question. So the question is which city has more spread? That's the question. Okay, so before we even calculate it, just by looking at the data, what city do you think has more spread? Be careful. Remember, range is also a good way to calculate, right? So most answers are B, and I think that is correct because B ranges from 0 all the way up to 1.75, right? So, and in the case of A, you only have 1 through 1.5, right? So I think city B is probably going to have a higher standard deviation. So let's take a look. So I'm going to go to Stat, Summary Stats, and Columns. This time I'm going to select both the columns A and B, and I'm going to choose standard deviation as well as the range. Okay, so standard deviation and the range. And let's hit compute, and here it is. So take a look. First of all, city B has a higher range than city A, right? 2 versus 0.5. City B also has a higher standard deviation than city A. So in both the cases, standard deviation and range, they suggest that city B has more spread or more dispersion. Okay, so first of all, you're going to enter your answers here. Notice that it's saying round to the nearest cent. So you're going to round this to the nearest cent, which is 0.22 and 0.77. Okay, and then what is the question? Which city has more dispersion based on the range? City B, because the range for city B is higher. Similarly, which city has more dispersion based on standard deviation? City B, because it has a higher standard deviation. Does that make sense? So this time what we did was we calculated the standard deviation all the values are 20. So if I just subtract 20 minus 20 square, I get 0. For all the values is going to be 0, right? So because the numerator is 0, standard deviation is going to be 0, right? Yes, Robert, there is a little bit of association. I wouldn't say correlation. I would say some association between the two. Although not in all cases. You can have the same range, okay? You can have the same range, but you can have different standard deviations. So that's a good theoretical question, but really no association between the two. But at least in this problem there was. Okay, let's move forward. All right. So now that we have done some, I call it data analytics, we are now going to be introduced to the type of variables. There are two types of variables, discrete and continuous. And so the question is, which one of these is discrete and which one is continuous? The number of points scored during a basketball game versus the time it takes for a light bulb to burn out. Now here's the way I do it. You have to ask yourself the question, can I count the variable that is given to me? Can I count it? Okay. If you can count it, then it's discrete. If you cannot count it, but you have to measure it, then it is continuous. Okay. So my question to you is the number of points scored during a basketball game. Can you count the number of score? Okay. The number of points? Yes. Yes, you can, right? A team can score 90 points, for example, right? So this makes this makes this distribution or this random variable a discrete variable. Okay, and another way to tell a discrete variable is it does not take any values in decimal points. It will always take values in whole numbers. So you can see that the points can only be 0, 1, 2, 3, 4. You cannot have a basketball game with a point 2.5, right? Or 90 point, 6, 7 or something. You can only have whole numbers. That's a second way to tell whether it's discrete or continuous. So that's why this is the right answer. Continuous variable can actually have decimal points. So the time it takes for a light bulb to burn out, you can't count that time, right? You have to measure the time. Therefore, this is continuous. And because time can take decimal points, right? Decimal points can represent, say, for example, seconds, milliseconds, microseconds, right? So therefore, your right answer is that the random variable is continuous. The possible values are t is greater than 0. You can have 0.5, 0.6, 1, 5 seconds, 5.5 seconds, right? And so on. So you can have decimal points. So therefore, this is the right answer here. Does that make sense? So really the only way to ask yourself, ask the question to yourself is, can I count this variable? If you can count it and it takes whole numbers, it's discrete. If you cannot count it, you have to measure it and it takes decimal points, it's continuous. Okay? All right. Now we're going to jump ships again. We're trying to cover various basic concepts of statistics so that next week we'll be ready with a much more stable concept. But anyway, now we're going to cover probability. Okay. And one of the fundamental rules of probability is when you have, so the question here says, determine the required value of the missing probability to make the distribution a discrete probability distribution. The reason this is a discrete probability distribution is, first of all, it is a distribution. Okay, we can all agree on that. It is a distribution because it has a set of numbers given to you. So this is a distribution. It's a probability distribution because they've given you the probabilities associated with each of the numbers that's given to you in the distribution. Okay, so therefore this is now a probability distribution. Why is it a discrete probability distribution? Because the values that x take are discrete. They're whole numbers, right? They're not in decimal points. Therefore, something like this is a discrete probability distribution because it has discrete numbers, it has probability associated with each number, and it is a distribution. So it's discrete probability distribution. The question is, what is the value here? What is the missing value? So one of the fundamental rules of probability, yes, fundamental rules of probability is that sum of all probabilities, I'm going to just call it P of X. P of X means probability of the value X in a distribution must be 1. Okay, so when you have a distribution, probability distribution like this, the sum of the probabilities must be equal to 1. Okay, so now let's work off of that. If I work off of this definition, then what that means is I should take 0.15 plus the unknown plus 0.28 plus 0.28, and this should equal 1. Okay, right? Because I should take all the probabilities, add them, and they should equal 1. Now, I should be able to take all these and add them together. Okay, so I'm going to add them together, and I get 0.71 on the left side. Okay, so I get the unknown plus 0.71 equals 1, right? And so what is the unknown? The unknown is simply 1 minus 0.71, which is 0.29. Okay, so just subtract the sum of what's given to you from 1, and you'll get your missing value, 0.29. So this missing value here is simply 0.29 because you have to sum all this to 1 and then get this as 0.29. Okay, this is a more interesting problem. So in this case, we have a probability distribution. The probability histogram to the right represents number of live births by a mother 49 to 54 years old who had a live birth in 2012. Okay, so here's the number of children and the probabilities associated with each value. The first question is, what is the probability that a randomly selected 49 to 54-year-old mother who had a live birth in 2012 has had her fourth live birth? So what is the probability? Basically, the question is, what is the probability when x equals 4? So what is the probability when x equals 4? So Jennifer says 0.109, and that is absolutely correct. These are your probability values given to you. And here's 4, right? So what is the probability? 0.109. Very good. What is the probability that a randomly selected 49 to 54-year-old has had her fourth or fifth? So what is the probability that x is either 4 or 5? Either or. Sandra, can you type it? Yes, you have to add them both. So can you type it separately and then put a plus sign in the middle? So then everyone will follow. That would be great. Very good. All right. So what you do is what Sandra says is that you take probability associated with 4, which is 0.109, and you add it to the probability associated with 5, which is 0.103. So you add these two together, okay? Because probabilities can be added. Very good. Okay, so next question. What is the probability that a randomly selected 49 to 54-year-old mother who had a live birth in 2012 has had her sixth or more live birth? Okay, so what is 6 or more? You don't have to add them, just type them separately and put a plus sign in the middle. 6 or more. Excellent, Robert. Kelvin, very good. Yep, Donna, that's right. So you take 0.035 plus 0.039 plus 0.045. Okay, you add them all together. Excellent. Okay, now we have a little bit of a challenging question here. If a 49 to 54-year-old mother who had a live birth in 2012 is randomly selected, how many live births would you expect the mother, okay, to have? So if you randomly pick a 49 to 54-year-old, the question is, on average, how many children do you expect, okay? Or how many live births do you expect on average? This is the tricky question, okay? Because you cannot just take, 8 and divide it by, um, or take the sum of this, okay, and divide it by the number of bars or whatever. Can't do that because you have probabilities associated with each value. Think of the probabilities as weights. What you have to do is calculate the weighted sum in this case, okay? So here's the way I would do it. So you have, for example, x and p of x. And let me actually write it down this way, p of x. And you can see that x goes from 1 to 8. So I'm going to say x is 1, 2, 3, 4, 5, 6, 7, 8. And then for each value, you have a associated probability. So I'm going to write that down. So it's oops, this is 0 0.103, 0 0.035. Okay, so all I did was I took my x values and I put the probability values in front of them. Okay, now on average, because we have to calculate an average, right? Do you generate a set of random? No, you don't have to do any of that. So we have the values for x and we have the p of x. All you have to do to calculate the average is to do the sum. Okay, remember this is the sign for the sum of x times p of x. Okay, so you take this, multiply it by this, then take this, multiply by this. Okay, whatever the answers you get, you keep adding them. Multiply, add, multiply, add. Keep doing it for the rest of them. Okay, now we can do this manually, or better yet, we can do this in StatCrunch, and it will answer. Someone had asked earlier how to use expressions in StatCrunch, and I'm going to show you how to do that now. So what I'm going to do is, unfortunately, you can't open this data in StatCrunch. So what you have to do is click on question help and click on StatCrunch. You're going to have to type this, which is a little bit of a pain, but let's type it. Okay. And okay. So I have my x and I have my p of x. So I have the x values and I have the probability of those x values, right? And I can verify if I do a sum of the probability, this should be 1. If I do a sum of the probability, I get 1. So this column is 1 and that I'm good, okay? So now let's calculate the average. Remember I said the average is this multiplied by this multiplied by this, keep summing them. Let me show you how to do this. So first thing to do is I'm going to calculate, I'm going to go to data, compute an expression, and I'm going to say x times p of x, okay? So I'm going to type x times p of x. X is this column, p of x is this column. So I'm multiplying them here, and I'm going to save that answer for each row. It's going to multiply them, and I'm going to save it in this column var3. And I'll just call this xpx. Okay, so let's compute. Okay, now take a look at this. It gave you the multiplicative answer here. Okay, 1 times this, 2 times this, 3 times this, and so on. Now all I have to do is sum it. Remember I said you take these the multiplied answers and you sum them. So I'm just going to go to stat, summary stat, column. I'm going to take my xpx and just sum it. And there you go. The answer is 3.063. 3.063 is when you round it to 1 decimal place is 3.1. Now let's take a look at what it looks like here. If you were to take a simple average, right, you would probably fall somewhere here. But it's closer to 3, and the reason it's closer to 3 is because you have these higher probabilities, right? The smaller values are, more likely to occur than these larger values. So therefore the mean is not here somewhere. It's pushed to the left because it's more likely to be in this region. So it's 3.063. Now I just had a thought. Wonder if you can also do something like this. Let's go to data. Let's go to compute. And let's go to expression. And I wonder if I just say the sum of x times p of x. Okay. So instead of just calculating x times p of x, I'm going to say sum of x times p of x. And I'm going to put it here. SXPX. Let's see what happens here. So it's going to give you the answer here somewhere. And yep, it works. You can see that it gave you 3.063. Just what we calculated earlier, right? So it's a different way of getting the answer. You can do it either way. You can first calculate xpx and then use the stat summary columns option to sum it, or you can just use the expression and just type this sum of x times p of x, and it will just do it and put it here. Okay, I like this one a little more than this. Okay, any questions? And then we are at the last question. Before I go, I will show you how to access the data set for general so that you know how to access it. Okay, and this problem is very much the same as the one we solved. Now, the only trouble, or the only, I guess, challenge here is to set it up. I'll show you how to set it up. So suppose you have a life insurance company that sells 190,000 one-year term life insurance. Okay, so there's a life insurance company. The way they work is you pay them a monthly premium and you get a life insurance policy. Okay, so that in case, um, if an individual is unable to survive, okay, then a lump sum payment is made to the survivor of that person. Okay, so for example, in this case, when it says a life insurance company sells 190,000 one-year life term insurance policy to a 22-year-old female for $220, what that means is the you know the female pays $220 per year, okay, and they get a insurance policy of $190,000. So in case the female is, if the female does not survive, then this lump sum is paid to the survivor of the female. Okay, that's what that means. Now, obviously, it's a 22-year-old female, so the probability of survival is high, and obviously, it is almost 1. It's 0.999654. Okay. The question is to compute and interpret the expected value of the policy to the insurance company. The insurance company has to stay in business. And so the question is, if this was the insurance policy, what would be the amount of money made by the insurance on average? Okay. So obviously it looks like a kind of like a tricky question, but let's break it down. Okay. So The way I do it is I start with my favorite x times p of x. Okay. So what is x? Actually, let me also say, let me write it here, x times p of x. And here I'm going to say scenario. Okay. In the first case, say it's the female survives. If the female survives, the x is, okay, the x is, I'm going to define x as the money made by the company. Okay. The money that the insurance company makes. I'm going to say dollars. Okay, just say made by company. Okay, you know what I mean. So how much money did the company make? The question is, how much money does the company make if the female survives? So given in the question, if the female survives, the company does not have to make any lump sum payment to anyone. What they make is $220 for that year. Okay, because the female has to make that payment to the company. So it's plus 220. Plus means they made money, right? The money came to them, to the company. So it's plus 200. So what is the probability that they make $200? Well, the probability is that the female survived. So it's 0.999654. So do you all agree with this? Do you all agree with this first row here? Survives, money made is $200, probability is 0.999654. Yes, plus 200. 220, sorry, 220. Sorry, yes. Thank you for pointing that out. 220. Because it's $220 here. The 22-year-old female is going to pay 220. Yes, it is late. Okay, so 220. I guess I'm imagining $100 bills right now, right? And they can only be either 100 or 200. All right. So 220 is what the company makes. What is the other scenario? Does not survive. What happens if the female dies? Well, the company still makes the $220 payment, but boy, they have to pay out $190,000, right? They have to pay $190,000 in a lump sum. Excellent, Robert. Payout minus the premium. So from the reference of the company, they are losing how much money? They're losing 220 minus 189,780. Okay. Okay, that's how much money they're losing. And obviously, I remember I said survival has a probability. Obviously, does not survive also has a probability. What is this probability equal to, do you think? What is the probability that the female does not survive? Excellent. It's 1 minus the probability of survival. Okay. The probability of survival is 0.999654. So what is the probability that the female does not survive? It's just 1 minus 0.999654. Right? 1 minus 999,654. So it's 0.000346. Okay? Is this clear so far? So we have this and we have this. Okay? So it makes sense, right? This is a young female, 22-year-old. Okay? And because it's a 22-year-old, a young female, the probability of death is very low, right? So in other words, the probability that the company has to make this huge amount of payment is very, very low, right? It's very low. The probability that the company actually makes $220 is fairly high, right? So when you take many, 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 many females, okay, 22-year-old females, you're gonna, the company's gonna make money. But how much? Easy. Our favorite, sum of x times p of x, right? Let's do this. Open this in Stack. I'm gonna open StatCrunch, and let me push this on the side. So I'm gonna type out the numbers that I calculated. The first said survival plus 220 does not survive minus 189,780. Probability 0.999654. Probability of not survival 0.000346. Right? What are we getting? So we have to calculate x times p of x. This is my x. This is my p of x. Can I calculate sum of x times p of x? Yep. I'll go to data. I'll go to compute. I'll go to expression. And I'll type sum x times p of x. And put this in. This is the expected money, or I can call it whatever. I can call it SXPX. And I get $154.26. So what happens is sometimes the insurance company will have to make the payment, will have to make the large amount of payment, $190,000, to some 22-year-old who will die, right? But in most cases, they will make money because most 22-year-olds will survive. On average, the insurance company will make $154 per 22-year-old. That's an excellent, excellent business, wouldn't you say? Because most 22-year-olds are expected to survive. And so this is the answer to this question. $154.26. And then it says, which of the following interpretation of expected value is correct? Well, the insurance company expects to make an average profit of $154.26 on every 22-year-old female it insures for 1 year. Okay, so the more number of younger folks they can get, the more money they will make. Obviously, this equation is dependent on age. So if you had, someone who was around, say, 60 or 70-year-old, then the policy will be different. Your premium will be higher because the probability of survival is lower than a 22-year-old. Okay? So, and that is it. Those are all the questions. We've covered all the questions this week. So I think that after this, you should be able to easily finish the homework. Now, I do want to quickly show you how to access the journal. So let me quickly go over that. So the journals are given here. So you're going to go to your learning module. And you're going to go to, let me see, module 1. Yes, Kimberly, just give me 1 second. I'll show you. And in here, you're going to go down to where it says 1-4 journal. Okay, this is the extra credit as I mentioned last time. If you click on it, it gives you the problem set. This is the problem set. Okay. Okay, now I'm not going to read the whole thing, but essentially what it's saying is find this data set in StatCrunch. And I'm going to show you how to find it. Find it in StatCrunch and then answer these questions. All these questions, we've covered them today. Okay, they're all about outliers. All right. You have to calculate the mean and the median of various variable names here, like TPCP. These are all given to you in the data set. So you can easily calculate the mean and the medians and find the outliers, create some graphs, okay? That's not the hard part. I think the harder part here is the finding the data set. So let me show you how to find the data set. Yes, these are optional. You don't have to do it. It's 10 extra credit points. So your assignment is 65 points. So 10 out of 65, I suppose, is about 15% of your, that's a pretty decent chunk. There's no due date for generals. So, but I would suggest if, it's easier to do it as you do the modules. Otherwise, you'll forget how to calculate this stuff. Okay, here's the way to find the data set. Go to data, okay, and then go to load. By the way, somebody had asked, Kimberly had asked, how did I do this? So here's it. Here's how I did it. I had x, and then p of x, and then I found my sum of x times p of x. You can view the recording to see how I did it. Anyway, so you go to data, and you go to load. And under load, you're going to go to shared data sets. Okay, this is a repository of various data sets that MyStatLab has. Click on it. Okay, it's going to open up all these different kinds of data sets. Okay, and I don't know why there's a data set on AC/DC here, but so what you're going to do is you're going to now it tells you to type this. If you look at the um, if you look at the problem set, it tells you to look for this data set: SNU MAT 240 15 EW3 Manchester weather. Okay, you don't have to type the whole thing. Just type Manchester. Okay, I used to love AC/DC. Okay, Manchester. All right. So you type Manchester. I mean, yeah, I still like them, of course. So, okay, let's type Manchester and then click go. And it's going to open up these various data sets. All right. Now, what you have to do is look for the data set that has the owner name as David SZEC. Okay, David C is the owner of the data set. This is the data set that you're looking for. If you click it, it's going to open the data set here. Okay, so obviously this is a pretty large data set. There are so many variables here, right? And then look at all these values, right? And the variable that you're looking for is TPCP. So let's look at TPCP. TPCP. Here it is. See that? TPCP. This is the variable you're interested in. Okay, so I'm not going to use this, but let me show you. Say the variable I was interested in was this HTDD. Okay, so you can see all these different different values here. Let me show you how to calculate the mean and the median of this. Obviously, it's very easy. You go to stat, you go to summary stat, you go to columns, and just choose the variable that you're looking to analyze, and then just highlight mean and the median. And hit compute, and take a look at that. Did you see how we have so many values here? See that? All these values, this is a large data set. Look how easy it was to calculate the mean and the median, right? Similarly, you can do all sorts of stuff. You can do mean, median. You can also do standard deviation. You can click on standard deviation, and I can even do range. Look, look how easy it is. See that? Mean, the median, standard deviation, and the range. It's so easy to calculate all this stuff. And you can do comparisons. You can do more than one variable, compare them, and all that. How nice is that, right? This is your general assignment. How easy it is now. So I think the journal is very easy. It's really nice that you have 10 extra credit points every week. So I would suggest to take some time and do it. And also you get practice with large data sets, which is the reason you're learning statistics. It is to analyze, large data sets, not to analyze small data sets. This is this is also a practice of a real world kind of data set that you're more likely to see in your careers. Okay? All right, any questions? And we're done for tonight. And if the original poll was good, then we'll see who wins tomorrow. Okay, Calvin, you can type your question. Just go ahead, type your question. Any questions? Any other questions? Kathy, I think the best way to get extra help on StackCrunch is to just practice. Take a look at my webinars from Tuesday and tonight. I'm going to post a recording. Just practice. And I believe, after about 2, 3 times, you're going to get absolutely perfect in StackCrunch. Don't be shy on, using it over and over again. So, okay, Calvin, no problem. How are we putting answers in the journal? Good question. Okay, for journals, let me share my screen again. When you have your answers ready, what you can do is here you'll see there's a button called Create Journal Entry, right? You're going to click on this Create Journal Entry. And once it's open, you can do two things. You can either type your answers in a Word document and upload it as a file, okay? Just upload it here, or you can type out your answers here, okay? So either way you can do it, and then just post entry, and that is it. Very simple. Okay. All right, let me stop the recording and